Nicholas Lewis is tuning in. This is great. Scott Harris is tuning in.
I see an old scope and then a new scope.
All right. Nicholas Lewis, we're going to start with you.
Okay.
Hello.
How's it
Can you hear
going?
me? Pretty good? Oop, hang on a second. I lost the screen. There we go.
Hey there. Welcome to our show and tell.
Hi.
Welcome to Show and Tell, everyone. We're going to get to you first and show us your project.
Okay, so I'm going to share a little LCD SD card breakout board I made.
Yeah.
So here, I'll swing around over here. I was actually going to try and show this last week, but my computer freaked out. There we go.
Huh.
So I've got an Arduino here,
Uh-huh.
and then one of your RGB LCDs here.
Oh.
So I had, so it's just running a simple sketch here where it's just running through the colors. It's kind of a modified version of yours, your sketch. It also has an SD card on here. So the kind of the inspiration behind this is I had a project all out on a breadboard, and it had the SD card stuff with the level converters and then the LCD. And I wanted something a little bit simpler to just be able to just plug the wires in without having to do all the grounds and the power and stuff. So the kind of neat part of this, though, I'm going to unplug it and pull the LCD off so we can see what I did underneath. So I actually did this with a little PCB that I'd made to break out for the SD card, the surface mount thing.
Uh-huh.
But then I did it all wire wrap.
Oh.
Look at that.
Yeah.
Try and get that in the camera there.
Yeah.
So it's all wire wrap. I had a bunch of, maybe that'll help a little more light. I had a bunch of wire wrap stuff that I'd gotten from my grandfather, who was an electrical engineer, and I thought this would be kind of a cool little project to do all wire wrap. So it's all wire wrap with the exception of the little SD card breakout that I'd made before that gets the surface mount to the through hole.
Yeah, wire wrapping isn't really done anymore, but up to like the mid-90s at MIT, it was still a standard. The classes were taught with wire wrapping.
Yeah.
And then they moved to breadboards and software simulation.
Yeah.
But yeah, you had tools, and you'd spin it around to wrap it, and you could make really high-speed circuits. Like you can do pretty good stuff with wire wrapping. You don't even you don't even know what I'm talking about.
No, I do.
You've seen wire wrapping?
Yeah. I like what you did because you know what's inside of it, and that's why it makes it special. Like if you just leave it on your desk, it's like, oh, it's just like some LCD thing. But I like that when you pop it open, you can see this thing.
He's got a wire wrapping tool. He doesn't even use it by his hand.
Yeah.
It's
I have an electric wire wrap tool.
Wow.
So yeah, it's hard to find some of the wire wrap parts. But I was going to say, luckily I had a whole bunch of stuff that I'd gotten from my grandfather that I used to do this. So.
So rad.
Yeah, one day we'll be talking about through-hole parts. Remember when we had through-hole parts?
Yeah, that's true.
Woo! That was crazy. Before we all had picking places in our homes.
Yeah. Cool. All right, this is a good project. I like how you are like, oh, it's an LCD, and then you're like, electric wire wrap tool.
Yeah, wire wrapping. Yep.
If you remember, take some photos of the wire wrapping and either send us a link or put it up in the show and tell post. And we'd love to, if you get some good photos, we'd love to write about this up on the Adafruit blog.
Okay, yeah, I have a blog post a little bit with some more detailed pictures. I didn't take any actual of the wire wrapping process, but I have some better pictures of the board and stuff on a blog post I can post up.
Yeah, get the wire wrap photos there. I think people want to see that. It'll be good for the youngins.
Yeah.
Yeah. Okay.
All right, thank you so much, Nicholas. That was cool.
Yep.
All right, Scott, you came in next.
Scott, who's got the scope and the other scope. Show us your awesome project.
Yeah.
Oh, wait. Hello?
Oop. I think your mic
can't hear
is muted, Scott.
I'm clicking on
Can't
it.
hear you. Oh,
there you go.
There you go. Nope, no?
It was for a second.
We heard you for
How
a
about
second.
now?
Yeah.
We can hear you now.
Okay, great. So I built one of these coffee can radars that was on MIT OpenCourseware.
Oh, cool.
Okay, cool.
Antennas. And I got interested in trying to measure the SWR of my antennas to make sure that they were matched properly.
And
I
not
don't have
concatenated.
a vector network analyzer, so I built this. Let me see if I can switch cameras, see if this works.
This is like when you get on hold somewhere and they're like, hold on before I disconnect you. I think you just got disconnected. I know you're still there.
I don't think the camera swapping works.
Did this
But I
work?
can see in the background, sort of.
Yeah, your mic is cutting out, Scott. If you can,
Okay. Well, let me just
Oh.
lift up the laptop then, because it's hard to show.
yeah, there you go.
Really?
Okay,
Yeah,
I see
that's
it,
great.
yeah.
So I don't know if you guys can see this.
I can see it.
Okay, so what this is
Yep.
this is a plot of reflected power versus frequency on this 2.4 gigahertz antenna. And so this is the setup here, which I was hoping the other cam would work, but it doesn't. So I've got
That looks good.
I don't know if this is going to work or not. So I have a VCO for mini circuits, which is kind of like the Legos of RF. And I have an
I
amplifier.
love it.
And then I have a 3dB coupler. So the power goes to the coffee can antenna, and then the reflected power is measured by this power measuring unit for mini circuits. And so as I sweep the frequency on the VCO, I can plot the reflected power versus frequency. Then you can trim the antenna to match it to your radar that you're building, or whatever.
So the yellow trace is the VCO in.
Exactly.
Okay, so I can see right there when it peaks up at the highest frequency, you get the most reflected power.
Well, so the power
Mhm.
measurement thing is inverted, so higher
Oh,
is better on the scope.
Right. Sorry.
So, and what's interesting about these antennas is they've got resonances, so you don't get a flat response over the band.
Yeah.
So, but anyway, you can go in there and trim your antennas to adjust them, and you can do this to trim Wi-Fi antennas because it's the same band.
Yeah, how much did that analyzer cost you? Because we're only going to get one.
So these power measurement units for mini circuits are about $100, and I don't know if I can point to that. And the VCO is about $100 as well.
No, the analyzer, the LCD analyzer.
Oh, that's just an oscilloscope.
Oh, I see. You don't need to have an antenna analysis tool because
Exactly, because
But-
you know a network analyzer is super expensive, but for a
yeah,
couple
I was
$100
like,
you
dude,
can
that's
put
like a
together-
pretty. It looks like a scope, but yeah, maybe.
Yeah.
Okay, cool.
Yeah, no, I don't have 30 grand, so for a couple
Neither
$100
do I.
you can put together a swept sort of RF source and then a reflective power measurement system.
That's actually a good technique. We might have to do that because we have to design a 2.4 gigahertz antenna. So we were thinking like, should we rent or should whatever?
Yeah, well, we have a spectrum analyzer for when you did the
we
wave
do,
bubble
but
stuff.
it's just all it is a spectrum
It
analyzer.
just does one thing. Yeah.
Yeah, it doesn't do. It won't tell you really how good your antenna is receiving. I mean, it can kind of do it, but
Yeah.
not really.
No, that's a clever hack. Are you writing this up anywhere anytime soon?
I made a little YouTube video about it, but
Oh, cool. Yeah,
it's
put
pretty standard. Here's the parts, so if that helps.
a link to that. I think
Mini
people-
Circuits is in Brooklyn. They're
Yeah,
actually
yeah.
nearby. We see people with like Mini Circuit shirts on sometimes because like they're they do like the sponsored walks.
Yeah.
And I was like, that's weird. There's all these people with like Mini Circuits RF shirts, and I was like, is there
Oh,
like
that's
some
awesome.
RF thing? But they were doing like a walk for cancer, I think, and they all
Yeah.
did it together. We got that in Brooklyn. We should go over there and like go through their dumpster. They probably have some great stuff in there.
Oh.
Yeah.
Yeah, some high-end stuff.
Maybe we'll pick up some of their stuff and we'll try this technique when we do our testing.
Yeah, we definitely should. I love Mini Circuits. That's why I got the VCOs for the wave bubble.
Yeah. All right. Well, thank you so much, Scott.
Yeah, no problem.
Rock on.
All right. Next up is John Pillman. John, how's it going?
Oh, hey, how are you doing?
Hello. Hey.
Show us your project.
Okay, well, I want to say you've already mentioned grandfathers and coffee tonight. I am a grandfather, and I've always been envious of your bins. So I've got my parts sorted in coffee cans here.
Oh, I like that.
That's nice.
These are. I'm trying to get the camera up where you can see.
Yeah, I can see they're full of little parts.
Yeah, a bunch
Bigger
of.
parts.
We drink plenty of coffee in our office, and those are all Folgers cans. I do have a small project I'm working on right now, which is just an infrared sensor, actually an LED and an infrared transistor. as part of a model railroad I'm working on to sense the cars coming by.
Cool.
But that was it. Just wanted to join in and say hi, and I'll let you get on to the real electronics here.
Oh,
No,
no.
okay. People ask us all the time how to store electronics, and it's true. Like coffee cans and glass bottles are
Yeah.
a fun
If
way.
you don't mind, could you take a photo of your coffee can setup? Because I'd love to post that up on Adafruit and on Make, because those are the type of like storage hacks that people always like to hear about. If you could put a photo in the show link on Google+.
Sure, I'll do that.
That'd be great. Yeah, because like people love these types of things because they're always asking like, oh, you know, I want to store my parts. And is that a rack that you made, or it looks like a laundry rack? Is that?
Yeah, it does look like that. It's really just a couple of boards with dowels.
Yeah.
These are 7/16, so they're starting to sag a little bit, so you might go to 1/2 inch.
Yeah.
And I've been experimenting with cutting them in half to see if that would be any better, but it's not really.
Oh, they're not even made out of metal anymore. They're plastic now.
Yeah.
I'm out
Right.
of touch with the coffee cans. Not really cans.
This is cool. This is total recycle, reuse, everything. And
Yeah.
tonight's show brought to you by Folgers.
Yeah. Okay, cool. Thanks, John.
All right,
Great.
John. Thank you so much. All right, Jerry. We know that you're working on some project here.
It's spinning.
Hi guys.
Hey, how's it going? You're, just so everyone knows, you're in Hawaii.
Let's see. Am I muted? I should
No,
be.
you're all the way in
There,
Hawaii,
can you hear
right?
me?
Yep.
Okay. Yes, I'm in Maui.
That's great. It looks like you're next door. The Google Plus signal is very strong tonight.
The force is with us.
Yeah,
The
yeah.
Googlers love Hawaii.
Yeah, they like Hawaii. Maybe that's why they have a
Yeah.
pipe going right from
Yeah.
Mountain View to Hawaii. Show us your project. I know you've been working on this for a while.
Yeah. Well, I'm playing with your wire, the LED wire, which right now is just running the standard advanced belt demo.
Yeah.
Right?
I haven't. What I've got it going on right now is I built a box for with the micro racks stuff for it because I have to demo this thing tomorrow at TEDx, the local
pressure.
TEDx. It has. Oh no, no pressure, and nothing's. It's just barely coming together at this point. I've got the anemometer here, the wind vane. I didn't get the rainwater hookup. I didn't figure that was going to be too much of an interesting thing here. But I can spin these, and they give me analog values or range values.
Gotcha.
There is up on top, if I can get it to show. There's a pair of the Sharp infrareds. This one is near, and that one's a short distance and a far distance.
Mhm.
And over here is a sensor, a Max Biotics sonar sensor, which is pretty flaky. And then there's one of your color-changing buttons in the middle, which the light's not working.
You have plenty of time to work on this. So.
Oh yeah. The main control board down below is, or it'll show. This one here, which is one of the fretboard with the board under the Arduino with a prototyping board built onto it. But I put a wing shield on because I got tired of the wires falling apart.
Yeah. That's a good idea.
They keep popping out, so this one's all soldered in.
Yeah.
And all the connectors actually have these screw waterproof connectors on them. 4-wire connectors that I got from Cool Neon. They use them with their big LED setup.
Okay.
And they're a hard thing to find, some decent waterproof connectors.
Yeah.
I think you guys...
Yeah,
I think you guys pointed... Go ahead.
Oh, I'm sorry. Yeah, we're working on it. We're very picky, so. Anyways.
I understand, and Benny pointed me at these. I guess you guys pointed me to Benny, and Benny had these, which are custom for him.
Yep.
I thank you very much. And the other thing I'm trying to get, I wanted to put because the whole thing's going to run off a battery. I got a nice big 12 volt and a 12 volt supply from you guys, but I was going to run it with the Adafruit, one of your LCDs and the little serial board.
Yeah.
But for some reason, this isn't working yet, and so I may just scrap that and let it all go by itself. The idea is that by doing some hand waving, moving your hands around over the top of the distance sensors and spinning the various other things, you'll get different color effects going on, or changing how far up they go, or changing the colors.
Oh, that's cool.
Hopefully.
You have plenty of time.
Yeah.
Oh, what? I got another, at least 12 hours.
Yeah.
And I can get an hour or two of sleep.
Here's the thing: a project expands the space, the time available. So it's actually better off if you wait to the last minute, because that way you only get to spend. You're not forced to spend more time, right?
Yeah. Yeah, and I'm not wasting time making it ultra fancy by like laser etching the box too much.
Right.
I started doing some when I was trying to cut the box parts to size, but it was a little too much to get everything right. So I just said, okay, heck with that.
You got a lot of sensors. It looks like most of them are working, and you got the example code. So you'll be fine. You'll have something.
Yeah, the next step is I have another month until we have our Source Maui event, which is our local version of Burning Man. Uh-huh. And there I'm taking their 9-foot sculpture and wrapping it with this and maybe another roll or two of the tape and making it interactive for the people to play with. Oh, I forgot to say it's talking to a Teensy, which is the actual thing which runs the tape. So
That's a really good board for us.
A little bit of serial comms.
Yeah. All right. Well, thank you so much. And when you get this running, if there's a TEDx video, because they usually do video, please let us know, and we'll post it up on Adafruit.
I will. It's not actually for a TEDx talk. It's art that's going to sit out in the courtyard. But I plan to do a write-up on it on our blog and some other stuff.
Okay, Jerry. Well, thanks so much, and we'll see you soon.
We definitely will.
Okay.
Okay.
All right, we're going to get to Jeremy, and then we're going to check in with Chris at the end. So, Jeremy, you got about 5 or 6 minutes or so. Show us what you're up to.
Sure. Like many of us out there, I am addicted to Blinky and LEDs. And
hello, Blinky!
This is the Blinky support group. Hi, my name is Phil. I actually want to wear Blinky stuff now.
Yeah, but then I'll have a badge and I'll light it up and I'll be in trouble again. So these LED strips are really good, but they're 12 volt. And I went about a year ago to actually buy a decent controller, and I came up with nothing. And so I made one. So what I have here, I'm going to be a little tethered by my power supply here, so I'm going to go ahead and unplug this guy. What I have here is
I respect people.
I made kits, and so I have a 328 running the whole show. It has a DC barrel jack for just a DC input. It has a serial input with selectable RS-232 or TTL level serial. This is a Max 32 chip that does the conversion there. There's an IR sensor on it if you want to hit it with a remote. The MOSFET's controlling 4 channels, 2 indicator LEDs for the FTDI header for programming, and then these are the pin extensions down here on the bottom for unused pins of the 328. And there's a couple of tactical buttons over here. And then another cool thing is there's a header on the side here. So if you want this somewhere, I have a smart house that I'm going to be doing some pretty cool videos on. I just finished up some stuff today that I'll go ahead and post up on my blog. Yeah. But if you don't have a smart house and you didn't pre-wire 3 miles of wire in your home like I did, you can take an XB adapter from Adafruit, and then you can plug it in here, and now it is a wireless RGB controller. So
that's nice.
This controls 4 channels of LED. Oh, and it also has selectable 5 or 12 volt output. So you can power it with 12 volts, and it'll power these guys here, which run off 12 volts, or you can switch the jumper, and it'll run off. Sorry, I'm all over the place here on my camera. You can switch the jumper, and it'll run off 5 volts if you want to do a lower power LED strip or some custom thing that you want to do there. So.
Oh, this is really cool. I like that you just have this, like, you needed to make this thing specifically for your fully wired house.
Yeah, I wanted something flexible, and then I kept adding stuff to it. Like, I don't need IR, but I thought if you ever wanted this to run standalone, IR would be really handy to have, and the sensors are pretty cheap, so, I threw that on there, and I want to make this as flexible as I can. My automation system's pretty flexible, but that way, when I sell these as kits, you don't have to wrestle with the right kind of input. You have all kinds of options for different types of input. So
Very
that's my
cool.
project.
Yeah,
Sweet.
when you're ready to talk about it and announce the kits, let us know. We'll post it up on Adafruit, and this is cool. You're in the kit biz.
Yay!
This is my first venture. Yes.
Excellent. And it's open source hardware. I see the logo on there, so that's
Yes.
great.
Everything is. In fact, I just posted tonight. There's a build tutorial of 70 or 80 pictures of how to build it in the whole 9 yards. The code is up. Just the CAD files will be up too. So everything's open source. Yeah.
Oh, fantastic. That's great. All right. Well,
Okay,
thank you
sweet.
so much. We're going to move on to Chris, and then we'll do Ask an Engineer.
I like how it calls them tactical switches.
They're tactical. All right. All right, Chris, give us an update on RiderNet to get unmute your
Hey
mic.
guys, how's it going?
Good.
Okay. So this week I took a break from the coding because I had been working on the XNP for like a month, and I finished a new shield. I'll move the camera down to it. I'm calling it an XB. Let me turn it right so it can be well seen. So I have a crappy connection. It is a mega forward shield, but basically it uses one of your Adafruit mini proto boards. If I can get the camera to look right. It's the reverse of the way I want to go. And it basically, the XP fits on top. It has buttons. It has a little rotary encoder on it, so that you don't have to program the ID into the code anymore, into the sketch. You can just choose which router it is with the little encoder. It's got piezo, 2 little buttons on it, the status light, and then you can pull the XP off. If you pull it off, it'll stop. Actually, I'll show you one over here. Sorry, this one. If you pull it off, underneath it's got 3 different sensor connectors and 1 power switch tail connector. So it's like a RiderNet router all on a mini proto board.
This is cool. You
and
made a
basically-
shield. Yeah, you made a shield with a motherboard. That's really.
It's like a mini shield.
Yeah, that's really cool.
And yeah, I did it because I wanted to be able to load normal Arduino shields on top of the Mega, like the Wave shield or whatever, and it wouldn't get in the way. God, I'm not moving this right. But so then I got the other big shield done. It has sensors built into it and whatnot. So there's a router version and then a remote version.
Yeah.
And so
Oh, that's
that's
great.
it.
Well, as always, we have a big post with all of your RiderNet stuff because I know you did some updates, so we waited, and we're going to do a big post about that. But when you have this up, take photos. We'd love to show this as an example of what you can do with the Firma Proto.
Thank you. Yeah, this is using all Adafruit products except for the little encoder which I got from DigiKey. But I figured that
like
would
a
be
badge. Like I used one of everything in
Yeah.
my project.
Yeah, we were actually thinking of putting having a coin for it because there's some customers who have actually gone through it. Like they started out with like a Minty Boost and now they're all the way up to like the NETV or something like that. So we wanted to have like maybe a special coin with MOSFET on one side and maybe you on the other.
Meow, meow, meow.
That'd be cool.
Okay, well thank you so much everyone. This is a
This is a
fantastic
jam-packed
show and tell. This is great.
Awesome.
Okay, we'll see everybody on Ask an Engineer shortly.
There's actually
See you.
a coffee can packed show.
It's a coffee can. Back show.
Yeah.
I
Thanks,
like
guys.
Folgers. I actually like instant coffee.
Bye.
Yeah. Okay, bye bye.
Take care now.